Thank you very much for the kind introduction. I am really honored and thrilled to be able to contribute to this symposium, which gathers excellent scholars in several disciplines. I can honestly say that in all my interactions with Australian researchers in composition and performance, in archival and information studies, and in ethnomusicology, I've always been terrifically impressed with the creativity and energy and scholarship of these wonderful people. And I'm as eager to learn from you as I am to speak. So let me just start in here, and we'll have a chance, I think, for questions at the end. One of the most universal of musical skills is the judgment and timing, of timing in performance and listening. To hear and to play regular rhythms, to synchronize with other players, and to perceive many expressive effects of rhythm require, as Justin London has said, that we project temporal regularities and order into our environment. This activity we could call meter in a general sense. In the music of many cultures across the world, these regularities are manifested in sound or gesture as dance steps, clapping patterns, or timelines against which more irregular patterns of durations are perceived and regulated in production. Western art music, as it started to favor polyphonic textures without sounding timelines, developed explicit theories of rhythmic regulation. For a long time, these were expressed in the practical terms of contemporary music notational systems: rhythmic modes, then mensuration, then bar lines and meter signatures, without a lot of abstract thought about the nature of meter. But with the growth of music theory as a distinct listener-oriented discipline, especially in the last half-century, have come some significant attempts to define meter in more general ways that could be applied in musical analysis. I'll begin here with a brief sketch of those theories just to bring out some of their essential features, some of which I think have perhaps inclined us to construe meter a little too narrowly. The influential work of Lerdahl and Jackendorf begins with an open-ended conception of meter as a means of temporal measurement, but they quickly restrict their scope as they're seeking to describe the cognitive processes of a competent listener of Western art music. They model it in terms of synchronized levels of equally spaced beats. They require that every pair of beats at one level be either 2 or 3 faster beats apart, which I will call a tight hierarchy, and they require the time spans between beats at any given level to be equal. Now, they're careful to explain that their rules are style-specific and that one can loosen the requirements of isochrony and tight hierarchy, and accordingly, some theorists, often citing East European folk music, allow meter to include a single non-isocronous beat layer. Lerdahl's student, David Temperley, adapts this theory as part of a project to program a computer to analyze the meter of actual performances as encoded in MIDI. For the program to produce the results that he wants, he finds it necessary to require a tight beat hierarchy and beat isochrony, but he allows for modest rubatos and other small deviations characteristic of human performance. Note the title of his book, which suggests he's aiming to model cognition more generally, not just that of an enculturated listener of Western classical music. A related thread of rhythmic theory oriented towards musical analysis considers meter not only as point-like beats, but in related terms as series of equal durations or pulses. Maury Yeston analyzed passages into strata of pulses, or what he called levels of motion, and he coined the term rhythmic consonants for levels that are synchronized. Yeston and later Harold Krebs realized that some passages could be analyzed into layers of pulse that are not so synchronized. This slide shows Krebs's analysis of a Schumann passage into layers of minims, represented by the series of 2s, and dotted minims, the series of 3s, proceeding simultaneously in what he calls a grouping metrical dissonance. In some of my work, I've found that patterns of accent in some post-tonal music afford hearing various streams of pulse, entering, fading, overlapping in complex ways, offering the listener sometimes it's coordinated into metric hierarchies, such as at the left of the slide, but at other times offering the listener multiple uncoordinated options for a tactus, such as at the right. And Richard Cohn has shown how some passages of Brahms and Beethoven feature multiple streams of pulse. In this case, the streams subdivide the dotted breathe measure into distinct metric states, each corresponding to a distinct path in a formal metric space. In all these theories, measurement relies upon the presence of isochronous series of beats, or pulses. Now, although they were intended primarily for analyzing the Western art music repertoire, Justin London has explicitly staked them to psychological and neuroscientific studies of timing perception. This approach both broadens the scope of metric theory, but also restricts certain aspects of it. On the one hand, beats or pulses can be understood as the representation of the well-known phenomenon of entrainment. So meter as a pulse hierarchy can be understood to be present in all entrainable music, not just Western. Indeed, London says that he aims, quote, to stake out the widest possible range of meters found in both Western and non-Western practice, close quote. On the other hand, the psychological studies place constraints on the formal models. Some of the constraints are suggested on this slide as annotations to London's cyclic representation of quadruple meter. It shows a tight hierarchy of isochronous beats, like the formal model of Lerdahl and Jackendorf, but he cites psychological experiments as suggesting that not all conceivable beats are metric. They can be too fast or too slow to be referenced for timing judgments. It's just the text version of this. Moreover, against those theorists who hold that different beats can be attended to simultaneously, thus raising the possibility of metrical dissonance or independent metric states, he cites studies that seem to indicate that listeners can attend to only one process at a time. On this view, any representation of meter as multiple concurrent beats is a convenient but merely abstract model of a single psychophysiological process of attending that's periodic but complexly varying. Now, my purpose today is not to take issue with theories that have proven so productive for music analysis and psychological experimentation. I find London's synthesis compelling in many ways. But if we are interested in explaining meter in its most elemental and universal senses, it's important to consider examples of temporal regulation that are metric in the general sense that they involve measurement, but they are not so clearly explained in terms of a tight hierarchy of isochronous beats constrained by the limits that London has set forth. Many such examples can be found in musics across the world, and I've taken the opportunity to study some of the more striking ones, making careful timing measurements and correlating them with other features of the music. My abstract says I'm going to deal with 3 examples, but I'll give you a 4th one today. So in 4 examples, I will identify and describe various processes that are plausibly metrical in some of the general senses I've just outlined. So number 1. In a recording made in 1976, a member of the Gizra people in Papua New Guinea performs a solo on a bamboo flute to announce the coming of the southeast winds, perhaps something like we were just experiencing the last couple days. He cycles repeatedly through a fixed series of 5 long pitches in a variable non-isochronous rhythm. Each pitch is sustained between 1.8 and 2.4 seconds and is preceded by what I'll call a grace note group of 2 or more fleeting events. This slide shows a representation of the first 4 iterations of the cycle and labels each gesture alphabetically. The positions of the long pitches and of the incipits of the grace note groups correspond to their onset time relative to their respective cycle beginnings, which are aligned vertically at the left. On this slide, dashed vertical lines connect corresponding pitches in successive cycles. The way that they diverge and converge shows how the durations between the onsets of the grace note groups and the long notes vary, and makes evident why it's hard to entrain to a persistent beat. So let's see if we can get this audio going here. Despite the non-isochrony, a listener may sense some temporal regulation. The total duration of each cycle remains remarkably consistent for its first 5 iterations, varying no more than 1.2% from 14.44 seconds. Perhaps the performer maintains a silent internal pulse, or perhaps after much practice he has settled into a physical routine, but neither seems likely since he varies the contents of the cycle. Moreover, these variations produce trends of timing that are apparent in the specific way that the lines diverge and converge. For example, across the cycle repetitions, the duration of long note V diminishes, so that the onset of grace note group W appears successively earlier. Also, the gap before the grace note group of X widens. One purpose for these changes may be to make time for a new idea to be inserted into the 7th cycle, as shown at the bottom of the slide. But they're not consistent with this regular beat. Nevertheless, I believe we can hear some design in these timing trends through a different but simple listening strategy. Rather than try to entrain to persistent isochronous beats, we may consider for each event, can the time of its onset be predicted from the timing of the event or events that precede it? This approach draws upon Christopher Hasty's theory of meter as rhythm. Hasty says that upon the completion of a duration, not too long, we mentally project that duration into the future, and that projected duration becomes a measure for the timing of following events. If the inner onset interval to the next event onset replicates the duration, we feel that the projection has been realized. A single duration can be repeated very locally, but without creating pulse. This slide shows the 2 clearest ways in which an immediate repetition of duration can be perceived in this solo. In the first way, indicated by the arrows above the note heads, we attend to the durations beginning at the onsets of each grace note group. At each of those onsets, we are aware of a duration just completed, symbolized by the solid arrow pointing to that moment. And we can project that duration into the future in the sense that we'll be able to tell whether it's reproduced. This projection is symbolized by the dashed arc pointing into the future from that moment. If the inner onset interval to the next grace note group onset at the end of the dashed arc is close to what we projected, we feel that the onset is on time and that our timing expectations are satisfied, that is, that the projection is realized. The other way to listen projectively to the same series of events is indicated by symbols below the note heads. We may hear the durations beginning at the onsets of each long note. For each long to long duration, the right timing of the next long onset may afford the same sensation of realized projection. Now, to the extent that this performance can be heard to create and realize projections, we may say that listeners, and possibly the performer, are measuring time even though there's no pulse or pulse hierarchy. This slide displays all the realized projections during the first 4 cycles. The arc pairs above the staff indicate projections realized by the onsets of the grace note groups, and the arc pairs below the staff indicate projections realized by the onsets of the long notes. Now, the indicated durations vary considerably. They range from 2.4 to over 4 seconds. So a succession of solid arcs does not necessarily mean there's a steady pulse stream, because one arc could be a different length than the next of the solid arcs. This analysis is limited to those projections in which the second duration is within 5% of the first duration. This is a fairly stringent standard, but also selective. With only a few exceptions, no other pairs of successive durations are nearly that equal. I've run some statistical tests that give some confidence that the distributions of durations are unlikely to be by chance. This analysis reveals some trends in durational reproduction that may be heard to create a large-scale rhythmic design for this performance. So let me run through some of those interesting trends. In no cycle does a solid arc ever span the rest after long note X. This means that the durations from the events of group X to the corresponding events of group Y are never reproduced, so that the timings of the onsets of group Z always feels hard to predict. In contrast, below the end of every cycle, a dashed arc continues into the next cycle. This means that in every cycle, the attack of the first long note can be accurately anticipated. Otherwise, during the first 3 iterations, the only durations that are reproduced that exactly are between the onsets of the grace note groups. At the beginning of the solo, then, it's rewarding to focus on those onsets because our anticipation of their timing is satisfied. So let me just play the beginning of that and focus on the durations from each grace note incipit to the next grace note group. Okay. In contrast, later on, during iterations 4 and 5, it's only the durations between the long notes that are reproduced so exactly. So as the cycle repeats, we are rewarded for shifting our attention to those onsets. Okay, thus by attending to immediately repeated durations, we can observe consistencies and systematic variation that help us to hear formative processes across many cycles. The processes arise from the player's virtuoso control of slow rhythm in a passage that seems to subvert a persistent tactus. Gagaku is a type of ensemble music that's associated with the court and religious ceremonies of Imperial Japan. Its most popular composition, Eiten Raku, was analyzed by Naoku Terauchi for a book that I co-edited. She explains that it consists of a melody that's conceived to be synchronized with a percussion cycle, a specific series of events that define 4 isochronous 4-beat measures, as shown at the top of the slide. Note 2 especially important features of the cycle. There are just 2 strokes on the large taiko drum, the first heard to announce and prepare for the second main stroke on the downbeat. Notice also the rolls on the kako drum. The first is performed evenly, but the second is performed as a slow acceleration, which enhances the anticipation of the main taiko stroke. The indigenous conception of this composition associates this percussion cycle with a meter that temporally coordinates all the instruments. On the bottom of the slide, you see Terauchi's transcription specifying that the instrument's attacks synchronize on the beats of a 4/4 meter. For instance, at the vertical red line on the downbeat of the second measure, the ryoteki flute, kako drum, and shoko gong are shown to attack together, and on the downbeat of the third measure, the onsets of nearly all instruments are represented as simultaneous. In the distant past, it's believed, the tempo for this composition was fast and steady, but in current practice, it is glacially slow and also variable. Moreover, no conductor leads the ensemble, and the players gaze rigidly forwards, not even glancing at each other for the kind of coordinating cues that might arise, say, in a Western string quartet. In such an environment, it's not surprising that the instruments do not always synchronize exactly on beats that they share in concept. The right-hand side of this slide transcribes an authoritative performance of the passage by the Imperial Court Ensemble. It places the instruments' attacks horizontally according to their actual clock time. It shows that in performance, the conceptual metrical isochrony is obscured by the staggering of attacks. Listen especially for the moments of asynchrony indicated by the dashed diagonal red lines. These discrepancies are probably intentional, like the timing differences between drums and bass in a jazz ensemble. Yet, each melody part is being doubled by 2 or more players who manage to play these irregular rhythms together accurately. And as the green lines in the example indicate, there are also moments when the melody onsets coincide with the drum strokes very well, considering the slow and uneven tempo. The synchronizations are even more striking later in this performance, when 2 conceptually equal time spans differ considerably in real time. Consider, for example, how measures 9 and 10, those are the 2 measures on the top system, are longer than the measures 11 and 12 down on the bottom system. and how the last beats of measure 10 and measure 12, those are both on the right-hand side of the screen, are much longer than the other beats. The green vertical lines show moments when two or more parts, some consisting of multiple instruments, synchronize their onsets after some tempo instability. How do they do it? Well, in Western ensemble music, expressive tempo changes usually occur across series of short, conceptually equal durations, so the players can easily track tempo fluctuations by the changing attack density. Here, though, the tempo slows during long-held durations and during a kako gesture that's accelerating. Somehow the players, without a conductor or apparent visual cues, are measuring time exactly enough to achieve these alignments. So let me play this passage for you and you'll hear what I mean. A clue to how this is done may be found in Terauchi's description of Gagaku ensemble coordination. During any given time span, she says, one of the parts acts as a leader of the ensemble, and the leadership passes from one part to another on practically every beat. She doesn't explain exactly how that leadership is exerted, but by making specific measurements of durations in this performance, we can see that there are indeed brief, subtle, audible regularities distributed across the ensemble. I'll demonstrate some of them in measures 9 to 11 by again employing concepts of Christopher Hastie. In measure 9, on the second staff down here, the winds play two events, D and E, each conceived as lasting 2 crotchet beats. Now the players synchronize the onset of the E precisely with a koto attack, but the tempo of the crotchet beat is slowing, as shown by the magenta arrows above the score. The second one is 17% longer than the first. How do the winds manage to attack together with a koto on beat 3? Well, a good possibility, which I'm sure you've thought of, is that the winds are listening to the quavers in the koto, not to the crotchets. Indeed, Terauchi says that the koto leads the ensemble at this point. As shown by the blue arrows below the koto part, the winds place their E such that the duration from the previous onset of the koto accurately reproduces the quaver of the koto C sharp. So in Hastie's terms, they realize the koto's projected duration. For the purposes of synchronization, then, it doesn't really matter what the duration from beat 1 to beat 2 is. Meter in the sense of a persistent isochronous pulse is not needed for this synchronization. This technique of realized projection also accounts for more subtly achieved synchronizations in the following measure. At the notional downbeat of measure 10, 4 instruments attack precisely together. The magenta arrows represent one explanation for their precision. They're hearing and realizing the projection of the minimum. But that duration is 3 seconds, which is difficult to replicate exactly. Also, they're slightly late, but that just makes it more puzzling how they manage to attack together. Terauchi says that the biwa lute leads the ensemble here, and it's true that its arpeggiation climaxes at the moment of synchronization. Perhaps the other players just wait for the start of that arpeggiation, and then they time their attack based on the familiar temporal envelope of that gesture. But they only have 390 milliseconds to react. Some advanced preparation would be helpful. Listen again to the passage, especially for the crescendo in the winds that's indicated in my transcription with the little hairpins there. As shown by the blue arrows, that dynamic emphasis comes 1.38 seconds after beat 3, and 1.33 seconds after that, essentially the same amount of time, the biwa attacks the first note of its arpeggiation. If the other players hear this realized projection, they can accurately anticipate the biwa attack. As in measure 9, the synchronization here seems to involve a one-off projection, not an isochronous pulse. A similar process accounts for the most dramatic feat of synchronization at the notional downbeat of measure 11, shown at the right of this slide. Again, the conceptually equal minims are not realized as such. Neither are the conceptually isochronous crotchets. In particular, the last crotchet of the measure is greatly stretched. Yet there is synchronization in this measure. First of all, on beat 3 between a melody and a taiko drum stroke. Terauchi says that the small kako drum leads here, but it's playing a slowly accelerating role that seems like a poor way to establish either isochrony or slowing down. I speculate that the wind and taiko players are counting its stroke and attacking together on the 5th one. See what you think. The synchronization at measure 11, beat 1, realizes a durational projection that's set up by the sho, or the mouth organ. Look at the blue arrows. Almost exactly the same duration after beat 4 that beat 4 was after beat 3, the sho changes its fingering to produce a distinctly audible attack. Nearly exactly the same duration afterwards, all the instruments attack together on the notional beat 1. In other words, the last notional semi-quaver of measure 10 effectively reproduces the duration of the preceding dotted quaver. Let me just clap that for you. So I just clap those moments together. You can see they're pretty much isochronous. So the synchrony in measure 11 then may result from the anticipated replication of actual real-time durations, not from the notional meter. The tight beat hierarchy of 4/4 seems irrelevant. Okay, well, both the flute piece and Eitan-raku are very slow, and their feats of durational reproduction and synchronization seem at, or maybe even beyond, the normal limits for the perception and production of pulse. But there are examples of fast music across the world that also display synchronization and durational reproduction without clear pulse hierarchy or isochrony. One of them is a peyote song of the Kiowa tribe of the North American plains, which came to my attention when I was editing an essay by Victoria Levine and Bruno Nettel. Their transcription of the beginning of the song is given on this slide. It shows the singer's melody and mentions a rattle part, which the singer also plays, doubled by a drum, so I'll call its attacks drum beats. Here's what it sounds like. According to the transcription, the player first repeats a series of vocables, yaha no hi na ho, in an unchanging measured rhythm of 4 quavers, then what they say is a slightly shortened crotchet, then a quaver, making a total duration of just under 7 quavers, where they say the quaver tempo is about 240 beats per minute. In the 5th phrase, where you can see all the crotchets there, the singer substitutes for the last vocable 4 even crotchets that constitute a cadential formula. The next section then begins with phrases that repeat the beginning phrases of the first section. Meanwhile, the same singer shakes his rattle, doubled by a drum, with completely even and undifferentiated strokes, described in the transcription as constant quavers. Now, from this transcription, one might infer that the shortening of the crotchets in the melody will cause each successive statement of the motive to be increasingly out of phase with the drum beat. However, that would be not quite right, because it turns out that the rattle quavers are actually faster than the voices quavers, moving at about 280 beats per minute. Levine and Nettel ponder how the singer maintains such discrepant rhythmic structures in singing and rattling. One possibility, they say, is that the 2 lines are independent and have little to do with each other. In fact, some Plains Indians insist on the independence of the drum from the melody. Another possibility is that the musicians intend to provide a regular relationship, but they don't pay very much attention to the precision of that relationship between the 2 lines. Another possibility is that a very rapid gait could unite the 2 independent parts, and somehow they're used to hearing in terms of such short durations. However, considering that a 20th of a second, or 50 milliseconds, is twice as fast as the shortest possible IOI for a metric cycle, according to London, this possibility seems unlikely. The authors themselves discount the second possibility, and the first explanation also presents a conundrum. It implies that the performer is simultaneously attending to 2 different, very rapid tempos. Well, a more precise transcription gives a better handle on the nature of the measurement tasks that the performer is accomplishing. This slide displays the attacks of the rattle and vocables on a time-proportionate graph. It makes evident how rarely the voice synchronizes attacks with the rattle. For example, during the first phrase, each successive vocal attack comes increasingly late compared to the drum. Nevertheless, as the transcription shows, the voice and the rattle do synchronize exactly on the vocable ya that begins each phrase every 8 drum beats. Listen again now for the small-scale asynchrony, but also the regular synchronization every 8 drum beats, indicated by the red vertical line. The exact timings of the vocables show some striking patterns. This graph represents each vocal phrase as a pie chart in which the time intervals from the onset of each vocable to the next are distributed proportionately around a circle that represents 8 rattle beats. Evidently, the vocal rhythms do not conform to an isochronous 8 cycle. The durations also vary somewhat from phrase to phrase. Note, for example, the changing size of the light blue pie slice occupied by the second na syllable. Considering this variation, one might think there's no measured timing at all within each phrase. In other words, that there's no vocal meter. This would be analogous to what we have heard about Chopin's rubato, which his student Mikuli claimed. One hand, that's the one having the accompaniment, always played on in strict time, while the other hand, singing the melody, maintained the freedom of musical expression from the fetters of strict regularity, close quote. However, this graph suggests otherwise. It shows the rhythm of each phrase as a colored line and aligns the corresponding vocables of the phrases. The close similarity between most of the lines indicates that the singer reproduces a rhythm with impressive precision. Only the beginnings of the first and sixth phrases stand out as different, possibly for reasons I'll soon discuss. The consistency suggests that the rhythms do not involve only 2 fuzzy categories of duration, quaver and crotchet, but rather more and distinct values that the singer is able to reproduce. So the performer really does seem to be engaging simultaneously in 2 different acts of measurement in his singing and his rattling. Neither one of them is really metric in terms of the theories that I cited at the beginning of my talk. The repeated rhythm of the singing does not appear to be regulated by any beat. So within each phrase, we seem to have vocal measurement without low-level isochrony. Considering the drum beat, no phenomenal accent suggests grouping it into 2s or 3s. Its tempo 280 itself is too fast to be a tactus, according to Lenda. It's even rather too fast to be grouped subjectively into 2s because the resulting tempo 140 is somewhat outside the region of maximal pulse salience. And an experiment by Parncut has shown that hardly any subjects group a beat at this tempo into 3s. It's possible to hear the drum beats grouped into 8s, for sure, by the phrase incipits. But the point is that there aren't any intermediate levels of 2s or 4s that are articulated, so the beat hierarchy is not tight. There is a further remarkable feat of timing that he accomplishes. We've seen how he manages to place the incipits of phrases 1 through 5 exactly every 8 drum beats, despite not synchronizing with any intervening beats. 8 beats after the beginning of phrase 5, therefore, we might expect to hear another synchronization. However, there is none then, as he is already in the middle of the cadential formula, none of whose attacks falls on a drum beat. It seems as if he's lost his 8-beat entrainment. However, the next attack after the formula on the syllable hey synchronizes with the drum and comes exactly 16 beats after the beginning of the 5th phrase. It appears that the singer is reproducing a 16-beat, 3.5-second time span without synchronizing his vocal attacks with any intervening drum beats, nor with the 8-beat time span. Then you can also see that he shifts his beat right after that 2 drum beats over. So let's listen to that 16 here. conception of projective meter explains some of these observations. It does not require a tight hierarchy of beats, so it's not a problem for that theory that there are no isochronous levels between the drum beats and the regular phrase incipits. It also helps us to understand how the singer sets up and reproduces the 8-beat duration at the beginning of each section. Recall that the first phrases in each section, phrase 1 and 6, have slightly different rhythm than the other phrases. Specifically, their first few events are relatively isochronous and close to the tempo of the drum. Perhaps the singer recites the first 4 vocables in these phrases just enough in synchronization with the drum to be able to still mentally establish a 4-beat duration. He then projects the 4-beat duration forward in time and realizes it with the incipit of the second phrase, without bothering to synchronize the preceding vocal attacks with the drum. The realization of the 4-beat projection establishes an 8-beat duration, the projection of which he realizes with the beginning of the third phrase. Having achieved a way to measure these longer time spans, the singer need not synchronize his vocables with the drum or any other equal subdivision of the 8. By projecting and realizing the 8-beat duration, the singer also establishes a 16-beat duration. During the 5th phrase cadence, when the 8-beat pulse seems to disappear, the singer may be retaining and projecting the 16-beat duration, for he reproduces it without subdividing it into any plausibly entrainable faster beats. However, Hasty's theory doesn't really explain the consistent timings within the vocal phrases, nor how 2 different incommensurate timing processes could be operating simultaneously. Some further instances of metric multitasking are evident in a social dance song of the Jivaro, the famous headhunting tribe of eastern Ecuador. In this duet, a man and a woman sing different and flirtatious lyrics to each other. Each of them constantly recycles a different simple melody organized along 4 accented events, which I take to articulate beats. On this time proportional transcription, these events are shown with larger note heads, and the beginning of each cycle is indicated by a red W in the woman's part or a blue M in the man's part, followed by an ordinal number. So here's what the beginning of this duet sounds like. Their duet is especially fascinating because not only are their melodies different, but so are their tempos. The woman, starting after the man, completes 25 cycles of her tune in the time that the man completes about 20, with their tempos averaging about 76 and 62 beats per minute, respectively. Not only that, but neither of their beats is regular. These radar charts represent, for a typical cycle of each voice, the lengths of the 4 beats by the distances of the 4 corners of the diamond from its center. The asymmetry of the diamonds indicates the non-isochrony of the accented events. The woman's cycle has longer first and third beats and a shorter 4th beat. In contrast, the man's cycle has a noticeably longer 4th beat. Let me play that for you again and just focus on the woman and then the man. You can hear these differences in their way they time their beats. Listen to the man. Considering the different tempos and the differently irregular beats, it's hard to imagine how the singers could fit their parts together at all. Yet, of course, they're sharing a 5-pitch collection, so it appears that they're not simply superimposing arbitrary, incompatible songs. Indeed, the ways that they time their respective events strongly suggest that they're listening to each other and adjusting to achieve synchronization, even in this metrically bewildering environment. Coordination appears immediately, as suggested by the annotations on this slide. The voices begin as if they'll be in the same tempo. The woman places her first beat exactly when it would occur based on the time between the last 2 beats in the man's first cycle, 958 milliseconds to be precise. Moreover, although she does not place the remaining beats of her first cycle on his beats, she does place the first beat of her second cycle, that's the first green line, precisely on the 4th beat of his second cycle. He then reciprocates by placing this is the second green line, by placing the first beat of his third cycle on the 3rd beat of her second cycle. And this moment is especially marked because they sing exactly the same pitch. Both of these actions seem plausibly intentional. During the long inter-onset interval at the end of each cycle, each singer can orient briefly to the other's beat. So let me just clap these moments of synchronization for you in the opening. I'll point out the following interactions on a more abstract representation in which pitch and onset time of each beat in the woman's and man's parts are plotted on red and blue curves respectively. The green vertical lines mark the occasions when the two performers place their beats essentially at the same moment. The exact time difference is shown in magenta above. It ranges from exact synchrony of 0 milliseconds to, I went up I think to 9 or 10, which is essentially simultaneous. After these opening interactions, the man places the second beat of 3 consecutive cycles on a woman's beat. It's starting at about 22 seconds. A new and even more cooperative pattern of behavior seems to emerge. The man places the first beats of 4 consecutive cycles, that's his cycles 6 through 9, within 9 milliseconds of the woman's beats. You can see the first green lines there are all close synchronizations. The woman seems to notice, because at her 9th cycle, she stops singing words and starts to hum. As she does, the man speeds up his tempo to nearly match hers, using a new, faster rhythm that causes the first and third beats of his 8th cycle to fall on her 4th and 2nd beats. For the same reason, the first and third beats of his 9th cycle coincide with the woman's first and third beats. He takes an extra long pause at the end of his 8th cycle to accomplish this synchronization and to maintain his overall slower tempo. Okay, well, I'm going to play this again. I know it's really hard to hear your first time through, but I'll try to clap these moments of synchronization that you see with the green lines. It starts a little bit before this. So here we go. These coincidences initiate a remarkable passage in which he regularly places his third beat within 5 milliseconds of one of the woman's beats. The synchronization continues for 7 consecutive cycles. It's too precise and too persistent to happen by chance. Furthermore, in many of these cycles, the man's second or fourth beat also coincides with a beat in the woman's cycle. That is, the voices share 2 consecutive beats. Recalling the difference in their overall tempos, this is only possible because their beats are not isochronous, so that the duration of a woman's long beat can match the duration of a man's short beat. So let me just play this passage for you. It's tempting to dismiss these varying synchronizations as unintentional manifestations of subconscious neuronal mirroring. However, the singers proceed at different tempos, and there are never more than 2 consecutive shared beats, so the simultaneous attacks seem more intentional than automatic. Moreover, the changes that the singers introduce into their cycles as the synchronizations occur suggest that they're aware of the special temporal relationships and that one is able to judge timings in the other's tempo while still singing in one's own. Okay, well, I've presented quite a bit of data here, so let me conclude by summarizing the kinds of temporal measurement I've observed and positioning those observations with respect to theories of meter that restrict it to tight hierarchies of isochronous pulses, constrained by the limits on durational perception. First of all, we see some evidence that the performers are able to immediately reproduce very long durations with surprising accuracy. In 3 of the examples, the durations were 3 seconds or longer. More impressively, the flute players' phrases were essentially exactly the same very long length, despite considerable variation of their internal durations. The same accuracy over similarly long timescales has been observed in other repertoires, Norwegian fiddle music and Bolivian panpipe performances. Some kind of future-directed measurement is needed in order for different performers to synchronize. In all three of the polyphonic examples, we observe synchronization, either in conceptually isochronous, but actually highly variable and slow tempo, or when one or both voices had no isochrony. We even saw evidence that the performers could simultaneously track two different tempi, a topic that my colleague Eve Poudrier has been investigating. While Etenraku and the Hivaro duet showed some evidences of a non-isochronous quadruple meter, in the peyote song and the flute performance, there was little evidence of a pulse hierarchy, and durational reproduction could be explained more simply in terms of local durational projection and realization. Lastly, in three examples, we saw how performers were able to accurately reproduce rhythms that could not evidently be measured with respect to an ongoing pulse. Although all these measuring activities seem exceptional, I hope to have shown that they're not merely local aberrations, but are rather integral to the conception, execution, and formal and expressive aspects of these items. To the extent that we listen carefully and evaluate such feats of temporal measurement, I believe we'll be able to enrich the concept of meter and better appreciate the music of the world. Thank you very much.
Thank you so much, John. I'm sure we've got lots of questions arising from this wonderful presentation. Can I kick off by asking you one? For me, as somebody who studies vocal music, it is not really a theorist. The thought that springs to mind is that what seems common to at least a lot of these practices is that it's that humans don't think, of course, in clock time, and so it has to do with some kind of organic process, and that has to do maybe with breath and with the words of the pieces that are vocal, which have their own kind of intrinsic patterns. Is that something that comes into the way that people perhaps are lining up the structures of these pieces?
Perhaps two of these had words. One was the Kiowa song, which was just nonsense vocables. They don't have a semantic content. But he does repeat the same thing over and over again. In the Hivaro duet, though, they're constantly, I don't know if you noticed, but they're constantly changing their words. And so and they're fitting it to that cycle. So it's more like sort of a fixed, kind of like a fixed meter poem where they're sometimes add a couple syllables or subtract them. So I don't have a good, of course I don't speak the language, so I don't have any good sense of that. But I think in all, to generalize your question, I think that's probably true that there's a lot of things that are going on here which have to do with natural physical production of what's going on. And it's definitely worth studying. I guess I would advocate for considering that as a kind of meter, even if it doesn't fit the theoretical ideas of isochrony and beat hierarchy.
Sure.
Thanks.
So, so let's please have questions. Can I just ask you, because we're in such a big space, to speak up so everyone can hear the questions?
Yeah.
Please.
Yeah, thanks for a great talk, so many inspiring ideas. Just kind of a general question, because, I mean, of course, we don't know how much effort you've got into kind of handpicking these examples and, like, trying to figure out what is the control condition here, because, I mean, are some of these things accidental,
right.
If the performers intend these kinds of, like, negotiations between different metrical levels, or, like, did you have a sense of whether it's accidental, intended?
You're raising some really important methodological points, which I didn't have time to go into here. Let me just give a couple short pieces of information to relate to what you're saying, which I can't, address in total detail. First of all, where are these timings coming from that I'm measuring? Well, I mean, I make them. I look at the audio files. I look very carefully and listen very carefully, and I try to be consistent. So I hope I'm not biasing it. I try to get my students to do the same thing and compare. Unfortunately, since these attacks are not crisp attacks like you get in a piano, it's very hard to get an automated program to accurately put the attacks there. So my experience is that listening orally has been more accurate in looking at the waveform. So that's where the raw data comes from, is just looking very carefully and listening by ear and trying to separate these things out. Certainly doesn't eliminate the possibility of bias. What I did in a couple of the cases, I tried to run some statistical tests on the data, so I'd have a null hypothesis that these number of synchronizations would be by chance. It cannot be. For the flute one, I don't have the statistics right here, but it's very high confidence level that that those couldn't be by chance. For the hero, you don't even need to do the statistics, because going at those two different tempos, which I think I said were 74 and 62, if you put two beats going on that speed, they won't get within 10 milliseconds of each other in this time span more than 4 times, but they do it 28 times. So I don't think you need a statistical test to convince yourself that that's striking. So I'm not totally confident about the problem of bias. I'm very sensitive to that, but I have tried to pick fairly convincing examples where it seems to be fairly convincing in that way. Does that go to some ways toward?
Do you know if they have interviewed the performers? Do you know if they can send these things, or if they just happen?
No, and these are older recordings. The performers are long. In fact, the cultures of these performances, except for the Eitan-raku, are pretty much gone. I think these are all disappeared practices. So we're only working from recordings. We can't see, as far as the synchronizations, the Eitan-raku, the Japanese one, we know that they just don't look at each other. But for the man and the woman duet, they may be looking at each other and giving some physical cues that we can't hear on the recording. So that's a good question.
Yeah, in that last example with the man and the woman synchronizing, it felt like those two synchronized beats that
Kept coming.
I felt like I could anticipate when they were coming. Did that continue throughout the piece?
Yes, I showed you the beginning of the piece and sort of the central section, and there's 28 moments where they synchronize within 9 milliseconds, and there seems to be a kind of form where they begin more apart and not synchronized, but then they start to synchronize, and the woman starts to sing something different. Then she starts to hum and not sing, and she also starts to go to a different note that she didn't go before. Then they go back and they start to synchronize. So it seems like they're also hearing and anticipating things going on. There's a bit of shape there. So I'm not sure what you're hearing. I'd be really interesting to drill down. Yes. Interesting. Yeah, well, I can play you the whole recording later on, and you can see if that intuition keeps going. Part of that, I think, is something that I didn't analyze in the last one, which these synchronizations are, I think, within the realm of projecting and hearing realized projections, like I showed in the earlier one. So maybe some of your intuition is that you hear a synchronization, bump, bump, and then bump, bump is something you can anticipate based on what's happened before. But I haven't done the measurement. Maybe I should do that. Thank you.
Yes,
yeah, have you had the opportunity to look at 2 performances on a similar piece? Because presumably they're quite improvised.
Yes.
But are there common patterns that may occur on either occasions?
For 3 of the items, it's not possible. For Eitan-raku, though, this is a commonly performed piece. There are many recordings of it, and they do the same kinds of synchronization. I haven't looked at the exact timings there, but there's the same kind of local leadership that involves one person setting up a very local duration that's then reproduced. So even though the overall performance sounds a little bit different, you still get these local synchronizations that I think are the same technique that are going on, and what Teruichi responds to. So that's the only one I can say. And this is a problem, methodologically, this is obviously a problem in any of this research, is if you're only looking at one recording, you can't make any generalizations about intention. You can only speak to the audio trace and the listener's experience of it without attributing anything to the performer. Good point.
I had a comment question. Comment was, I'm interested in your view of it, that the first 2 mechanisms, the slow pieces, are actually seeming to be very similar from a performance perspective to what one does in expressive timing when it's not vibrato compensated. In other words, when the pulse rate does change. And I was particularly wanting to ask a question about the third one, the Keynote one,
Yeah.
with the kind of 8 against the kind of 7. I mean, how precise is the isochrony in the drum 8 and then the 17 in the past? And how precise is the synchrony that you describe? I mean, it sounds quite good, but how variable is it?
Yeah. In order to answer the question, well, to your first question, I agree. There's this kind of timing occurs in all kinds of situations. And I guess one of my next projects is I'm going to look at some performances by György Kurtag, who uses a proportional notation, and he also performs his own music. I'm interested to see how he uses this how he actually realizes this notation with actual time, because he only gives relative durations, not precise ones. To your second point, sorry, rephrase again, I just lost my train of thought. Oh, yes. To gauge the precision of how well he synchronizes with the rattle and drum, I slowed down the tempo 4 times, so I'm working with very, very long stretches of time, and I tried to listen to the transitions to the vowels that you hear. You can hear them fairly precisely, so I'm pretty confident that the synchronizations of those syllables every 8 beats is pretty precise. It's within a couple milliseconds.
And what about the regularity of the drum?
Again, I wish that the recording were good enough to be able to run a program on it to do that. I think it's pretty good, I'm trying to remember if I actually did that. Yeah, I did. It was, fairly good compared.
Even in the 17?
Pardon me?
Even in the bar with the 17 in it?
There's one with a 16 in it. You mean?
Well, 7 depends how you look at it.
Oh, it depends how you count it, yeah. Yeah. Yeah, it seems like it. I'll go back to the data. I don't remember. It's been a while since I've looked at it.
Yeah, and can I follow up with another?
Sure.
I'm interested in the man and the woman duets, and where we plotted the beat durations.
Oh, yeah. That was just for, yeah.
So it seems a lot like it's all about the duration of the 4th beat in a way. Is that, because the others seem relatively isomorphous?
Yes, especially in the man's. He sings his tune quite regularly. Remember, he's going at a different tempo from the woman, but his beats are pretty clear, except he waits longer after his 4th beat. So there's always some extra space there compared to his other beats.
Yeah. Is that by any chance aligned with the end of the phrase? Because that would reduce the issue to just the question of how long of a break do you take?
That's right. Yeah. And that's what I was speculating. Yeah.
Then I guess, I don't know what the lyrics are here, but that would align with an idea of like the woman being impatient or something like that, and the man being could align with all these terrible stereotypes. I don't know, maybe the lyrics.
Yeah. Well, to your first point, that is what I was trying to show. The first time, the very beginning of the piece, there is a moment where the man has this rest at the. Why is the name of this? Chopped off the screen there. Can't quite see the right-hand side. But the man is about to synchronize with the woman at the beginning of his next cycle there, which is just off the right-hand side of the screen. And he does have that 4th beat where he can wait, and he can actually, I think he has time to sort of listen to where she is, so he can make that. But it doesn't work other times. That space doesn't always happen at that point in her cycle. So, something like that's got to be going on for him to be able to do that. I agree. Now, the other point I was going to make was, can't remember.
The lyrics.
Oh, the lyrics. Yeah. They're singing different lyrics. He's comparing himself to a parrot and how beautifully dressed the parrot is. And she's talking about somebody's fragrance and how her fragrance is better than the fragrance of somebody else. So the texts are different texts, they're different poetry. And as I said, they're flirtatious, but they aren't exactly connected. They're both showing off. Yeah.
I know there's some interesting work that looks at cross-cultural differences in preference. For say, for example, like harmonicity, or like how much consonants and dissonance in harmonies that you like or dislike. Is there anything similar for, let's say, like metric dissonance, like looking at cross-cultural preferences, this sort of thing? So you maybe would assume in this culture that would be more attractive to or more enjoying music that has this sort of like complexity to it versus things that are a bit more kind of clear cut. Is there anything that speaks to that?
Yeah, this song is fairly unusual in the Hivero repertoire for sure. I don't think we have any ethnography that talks about their conception of meter at all, much less 2 different meters going on at the same time. Interesting question.
Like less like intellectual preference for that, but just like whether they like music that whether they're attracted more to Has this kind of rhythmic complexity, or?
You're asking an ethnomusicological question, which I'm not competent to answer, but I think it's an important one. And my colleague, when I work with my colleague, Michael Tenzer, who's an ethnomusicologist, we are constantly worrying about such things. I just haven't worried about it today because I'm not with him. But thank you for that observation.
Okay, one more question.
I would like to ask about movement in trends to these temporal structures in a regular listener in those cultures. Obviously, the performers probably spend a lot of time training and practicing the synchronization. But do you know in these couple of examples you were talking about how much there is some sort of a group synchronization going on? Because there are some examples of that with African music or non-African beats where sort of people dance together.
Sure.
Is there the case for any of these as well?
I can speak to the Japanese example, Etenraku, which I characterize as being a problem because the players aren't looking at each other and there's no conductor. However, if you look at there are some videos of that same ensemble playing some other pieces, and you can see that they have very stylized gestures. The lute players have this particular stroke where they, as they're about to play, they do this big gesture and then strum like that. And the other players, as far as I can tell, the other players can't see that because they're sitting in front. But there is some kind of stylized gesture that's involved in the timing there. And I think with the pitch bends and the other things that you hear in the flute parts, those also seem to be somewhat practiced and stylized. So I think I agree with you that some of the timing here, I'm making them out to be maybe more of a problem than it is, because this is an ensemble that only plays relatively few pieces, and they play them over and over and over again over a whole lifetime. So they really sort of know what the timing of this sounds like. And they may not be thinking in each case, oh, I have to get this beat exactly at this moment, because they just know how it goes and they play together so much. So I think that's an important consideration in all these things that should be taken into account. But again, I would say that's a kind of meter that we should be thinking about, even though it's not necessarily hierarchical or isocronous.
Great. I think we've come to a natural point of rest in the rhythm of this symposium. So can you please join me in thanking Professor Gagaku?
Thank you. Thank you.